Good morning, everyone, and welcome to the session on careers in text analytics and information retrieval. I just want to remind you that the session is being recorded. And since it's past 10, I will get started with my presentation. I plan to do a presentation about 45 minutes and leave time for questions at the end. But you can also ask your questions on the chat as they arise, and I'll try to address them at the end. Okay. Thank you very much. So I'll go ahead and get started with my presentation now. So as I said, I will be talking about careers in text analytics and information retrieval. My name is Halil Kılıçoğlu. I'm an associate professor at the University of Illinois iSchool. So before I get into text analytics and information retrieval, let me just give a little bit of background about myself. Of course, my computer started acting up right just then. Sorry. So I've been an associate professor at the iSchool since 2019. That's when I joined it. And I do research as well as I teaching. My research is in natural language processing and text mining, particularly with applications to biomedicine, biomedical applications. I also do research in machine learning, knowledge representation, and scholarly communication. So I do a lot of research in biomedical literature, scientific publications. Prior to joining to iSchool at University of Illinois, I was a research scientist at the National Library of Medicine. So I'm coming from a library to a library science school, basically. And prior to getting my PhD, I was a research software engineer at also the National Library of Medicine. So let me, so in this talk, basically, I will talk about, I will start by talking about text analytics in general. And I look at text analytics as basically a superset of information retrieval as well. So my discussion will include information retrieval as well. I will start by talking about what it is, what are the applications for it, and what are the practical applications for it. What kind of challenges do we face in text analytics? And just go really quickly over the pipeline of text analytics. When we talk about text analytics, what do we do actually? And towards the end of the talk, I will focus more on the careers. What kind of education? What kind of training can we get in text analytics in an information science program, for example? And what are the current career paths that are available for those people who are educated in or trained in text analytics. So what is text analytics? It's the process of deriving high quality information from textual resources, textual data. So it's a kind of data mining, data analytics, basically. And the kind of high quality information we're referring to here are basically trends and patterns that can be turned into actionable insights so that they can inform the decision-making process that we make in all kinds of industries and businesses. So text analytics is an applied field, and it builds upon foundations of natural language processing, or NLP, information retrieval, and machine learning. And sometimes we refer to text analytics as text mining or text data mining as well. In businesses, generally, the phrase text analytics is used, whereas in research, generally you hear about text mining or text data mining. So why do we need text analytics? Because we're basically drawing in text data. Society produces a lot of text data, but it's difficult for humans to basically manually analyze this data and make sense of the data. And what kind of text data are we talking about here? Some examples include customer reviews, like on Amazon, tweets, forum entries, forum posts, web pages, news articles, scientific publications, all kinds of things, emails, etc. So there's a need in a lot of different fields, business, science, law, where there are huge data sets of text that need to be interpreted and understood by humans, but it's just impossible for humans to do this. And therefore, we turned, and this is the problem of information modeling, and text data is difficult for computers. So a narrative text is not something computer is by default equipped with understanding, and so that's where text analytics comes into play. We need techniques to find relevant documents first, and from those relevant documents, we need to extract information that can help us identify patterns and gain insights. Information overload might sound like a problem of 21st century, but it's been around for a long time. This is a quote from 17th century, where the author is talking about the fact that there are too many books. This was only less than 2 centuries after the invention of the print. So you can imagine what kind of information overload we're dealing with now in the big data era. Just to give some examples, Google processes 5.6 billion searches every day, and there are 5 million tweets that are sent every day. And Facebook deals with 4 petabytes of data per day, 1 petabyte corresponding to 1 million gigabytes. So these are huge amounts of data, essentially, and this is mostly text data. And from my field, we've just seen we just witnessed in the last 2 years. Basically, there are over 180,000 publications, scientific publications on COVID-19. So this is in less than 2 years. And no one person is expected to understand these publications. It's impossible. And as a broad estimate, 80% of all data is estimated to be unstructured or text data. So we need methods basically to help us understand and make sense of this data. And businesses are turning to text analytics to be able to monitor the attitudes of how good their services and goods are being received by the customers. And it's enabling organizations to improve customer satisfaction and their communication with the public, and improving the efficiency and economy of their operations. So by using text analytics, businesses are basically gaining edge in the marketplace. And how is that happening? I mean, text analytics is essentially about scale. Of course, a human can read customer reviews and make sense of it, and basically interpret it for if you're a customer, if you're working for a business. But it's just a scale. They're just too much and too fast, basically. And text analytics basically gives us the tools to deal with this. So what are some of the applications of text analytics? What are some practical applications of text analytics? Spam email filtering, these are things that you deal with on a daily basis, sentiment or opinion analysis, recommendation systems, categorization of documents in certain ways, news articles, for example, and also prediction of stock prices from customer sentiment is another application. So let me just go over these really quickly. I'll start with spam email filtering. This is probably the one that you're dealing most on a daily basis. Basically, understanding whether an email is spam or not is one of the simplest applications of text analytics. And this is done on the basis of the content of the email. This is actually something I got, and it looks well written. It's not your typical spam email. It's well-formed sentences, but it's a spam email. And a text analytics tool basically would identify this as spam by the patterns that it's observing in this email. Words like compensate, $700,000, transaction. These are indicators that this might be a spam email. And it's the tool, a text analytic method, would be learning this from basically training on a large corpus, large data set of such emails. One of the reasons for one of the biggest success stories for text analytics perhaps is sentiment and opinion analysis. This is something it's been used for the last decade or so, although the research started much earlier than that, of course. So basically understanding customer sentiment over tweets, over forum posts, etc., is sentiment opinion analysis. On the right-hand side, you see basically Twitter sentiment for US airlines on a kind of a nice visualization, nice dashboard. Basically, and it's a in real time, basically looking at the tweets to understand how airlines are being evaluated. Another application of text analytics is recommendation systems. This is the example that I show here is about literature, scientific literature recommendation. So based on the fact that I was looking at this article on the right-hand side, upper right corner, this is Semantic Scholar. It's one of it's an online tool for literature search. It basically provided me these 3 recommendations, again based on the content of what appears in the text of this article that I was looking at. Yet another application is categorization, and this is generally used for news, for example, automatic categorization of news into different categories. You see this in Google News, etc. For example, the article on the news article on the left-hand side is categorized as politics, and the right-hand side is categorized as sports. Again, based on patterns, word patterns or phrase patterns that it's seeing. And this is, again, a simple kind of text analytics. It's not perfect, but it's the basic idea behind it is basically looking at words and phrases and using those as features. Yet another application of text mining is prediction of stock prices. The idea here is that for a company, you would observe the sentiment expressed in tweets about that company or news articles that appear about that company, and you would and from that you would predict how well the stock prices would do for that company. Usually there's a lag about a few weeks about this. I mean, there has been some research on this. I don't think it works perfectly, but at least it's been observed that Facebook's stock price was basically the sentiment about Facebook on Twitter or other sources like that was indicative of or predictive of its stock price increases and decreases. So those are some of the practical applications of text analytics that you might deal with on a kind of a daily basis. How does this work? How do we do text analytics? If you have some data, if you have some text, let's say customer reviews, what would we do in order to gain some insights from that? So text analytics is a kind of data analytics. So the pipeline for data analytics is kind of text analytics is kind of similar to that for data analytics. We first acquire the data, we pre-process data and transform it in a form that computers can use. And from that, we create models. This is usually done using machine learning algorithms. And once we create those models, we evaluate them, how good they are, how predictive they are, or we, in some cases, we just basically look at its output and try to interpret and understand understand what it's basically telling us. So I'll just talk about the steps in very, very high level. So as I said, we get the data. What do we do? The first thing is generally to pre-process it so that computers can process it essentially. These are the first two sentences from 1984, George Orwell's novel. And if this is our data, what we would do first is to segment it or split it into sentences. And there are tools that one can use for this. Next, we would tokenize each sentence. This is the typical pipeline. I'm not saying it's always done, but this is normally what we would do when we're using a text analytics pipeline. So, so once we have the sentences, we would tokenize the sentences into words. And as you can see, we not only identify the words, but we also identify the punctuations. We separate punctuations from the words as well, because they have meaning as well. And then typically we would use stemming or lemmatization on words to identify parts of the words that are so basically take care of some of the variability of the words. Let's say clocks versus clock, we would want to normalize them to clock, because for text analytics generally it doesn't matter whether it's plural or singular. We're not really looking at whether the words are grammatical or not. So generally we apply the step so that we normalize and reduce our feature space. So it's easier to apply machine learning models. Then generally we create a representation of the text in a way that computers can use. A narrative text is not something computers are good with. All it's seeing is a bunch of characters. It doesn't even know where the words start and end. So that's why we're doing these steps. So if we have, if the sentences here are our basically unit of interest, if these are the instances that we're dealing with, from the first sentence, we could, for example, create a word list of the words, a list of the words in the sentences. And here we have two lists like that. This is what's called a bag of words approach. We basically do not care about the order of words in these sentences. We're only interested in what words appear in the sentences, and that's it. And that becomes our representation of the sentence, basically. And at the bottom, you see this being represented in a kind of a table, tabular format. And this is the simplest form that the computer basically can work with. So that once we represent text in that way, then we can do modeling. Then we can apply machine learning models. And the idea that there are two paradigms here, basically prediction and exploration. When we want to do prediction, meaning we want to create a model so that we can basically categorize things later on unseen data. We can do categorization. This is prediction, and generally it's posed as a supervised learning problem. The idea here is that you have a data set that's already been labeled with the categories that you're interested in, and you learn a model on top of from this data, and then you apply the learned model to unseen data. Okay, so this is called supervised learning, and there are a bunch of machine learning algorithms that can be applied off the shelf, essentially, to such problems. Logistic regression, neural networks that are more in fashion these days. Also, and what this training process creates is a model, is a mathematical description of the data, essentially, that relates the features, that relates the words in text to the basically the labels that we're interested in. And in supervised learning, when we apply it to text, there are two types of tasks that we generally do. One is text classification. So these are assigning categories. And text regression is basically predicting numerical values from text. So for example, if you want to predict stock prices, this would be, since prices are numerical values, this would be a text regression task. Whereas if you're trying to determine whether a text is about, whether it's sports or politics, this is a categorization, because the categories that we're interested in are discrete values: politics, sports, etc. Okay, and this is the most common use of text analytics. We want to predict things. We want to, in practice, this is mostly what we do. The other paradigm is exploration. Here, we don't have labels, we just have text. And we're just sort of trying to understand or group documents together, or trying to understand what are some of the key themes in the data. And this is an instance of unsupervised learning, if you're talking about in machine learning parlance. And that there are two approaches also that are generally used here. One is text clustering, where we have a set of documents, and we're trying to see which documents are kind of similar to one another. So, for example, you can create a recommendation system based on this. So, if you're doing a recommendation system for scientific literature, basically you can cluster documents such that once you are looking at a document, it will give you similar documents. This is a case of clustering. Another well sort of understood model or way of doing this is topic modeling. This is very much used in, for example, digital humanities a lot, and other areas as well. Here, the idea is to basically understand what are some of the topics that arise from these documents, and basically representing each document as a mixture of these topics. This topic is, let's say, 40% about sports, 20% about politics, etc. You can think of it that way. So it's a more perhaps fine-grained way of creating clusters, and also it doesn't name these clusters for you necessarily, but it just creates a kind of high-level themes, which might help you understand your data set better. And these topics can be used for organizing, analyzing, summarizing document collections, basically. The key thing here is that there are no labels here that we're providing for training. It's basically just learning this by looking at correlations. So just to kind of give an example of text clustering, here basically these are movies. They were clustered based on their synopses. So what the plot lines basically, and you can and the movies that are in the same cluster are shown with the same color. So you see, for example, in orange, kind of suspense films, thrillers, Psycho, Pulp Fiction, Fargo, etc. And in purple, you see kind of crime films, Godfather, Goodfellas, etc. So this can be done on the basis of the synopses of these documents. And topic modeling, on the other hand, as I said, creates topics and basically associates each document with these topics with a kind of a percentage. Here, it's a scientific article, and it's basically a mixture of kind of genetics, life sciences, and computation, etc. And these are the words that are associated with these topics from these documents. And it's telling us that it's mostly about basically genetics, this document. So once we create these models, basically we need to interpret it or evaluate it. And if the model is supervised, then we do basically use evaluation metrics that are commonly used in text analytics on a subset of the labeled data set, so we can actually get estimates of how well our model will do when we actually look at unseen data or new data. So we get an estimate of that using metrics such as precision recall F1. And then we can use it on unseen data. On the other hand, unsupervised methods, clustering and topic modeling are mostly exploratory. It's intended to give you some insights by looking at the output, but generally it's even though they have evaluation metrics, they're not in the same way as they're not for prediction. So after giving that sort of high-level overview of what we do when we do text analytics, now let me talk about a little bit about some of the challenges that we face in text analytics. First of all, most of the things that we want to do have to do with the meaning of the text. So as humans, we don't have any problem interpreting the meaning of text, but computers are really bad at this. Language is really hard for computers. Because this is because natural language is hard. It's very creative. It's perhaps the epitome of human creativity in a way. It contains a lot of ambiguities on many levels, and we've kind of learned to understand the subtleties of text and writing, but computers are really bad at this. We infer a lot from common sense knowledge. We know a lot about the world, so we bring that knowledge into into understanding, but computers are not very good at this. And language evolves continually. We're talking in emojis most of the time. So this is the kind of thing that computers have a hard time with. And machine learning techniques that we use for modeling generally need a lot of data for them to be able to learn something. And generally, we need expertise for this, and it's hard to come by often. So just to give some examples of what makes the language hard, ambiguity is the biggest problem. You might hear the word, you might hear sentence such as, "One morning I shot an elephant in my pajamas," but this can mean two things: elephant in my pajamas or shooting in the pajamas. It's clear, it might be clear to you, but it's not clear to the computer. Sometimes the actual words that we used is not the intention. For example, here we're not asking the person, when we say can you pass the salt? We're not asking the person whether they can actually pass the salt. We're asking them basically to give us to pass the salt to us. In a way, it's not a real question. And we use a lot of things like sarcasm and metaphors, and these are difficult. When you say the opera singer was amazing, she sang all the notes, the explicit meaning of this is not really what you mean. So these are difficulties. And in a more sort of superficial way, language is also hard because there's a lot of irregularities. When you look at tweets, it's really hard to understand sometimes with all the abbreviations used or all the emojis and etc. emoticons. The last one is an actual tweet, and I'm not sure what it means. So just to kind of capture everything I've said so far, text analytics is a applied field, and it basically builds upon natural language processing, information retrieval, and basically machine learning, AI kinds of things, and it's a sort of a practical implementation of all of those things. It is practical. So, but that's generally not enough. Natural language processing is basically a kind of a more, perhaps a deeper way of understanding human language. So the methods that we use to basically understand human language better. As I said, when we want to process text, we want to understand it. Text analytics can do a lot without really understanding the text. Just using the words and phrases that are used, we can do a lot. On the other hand, when we really want to understand text, or when we really want the computer to understand text, we need to go a bit deeper than that. So natural language processing, or sometimes called computational linguistics, this is more about understanding linguistic structure and language understanding, more focused on understanding and representing, finding ways to represent the meaning of text. And some of the tasks that we look at in NLP are things like extracting information, extracting knowledge from text, answering questions, machine translation, document summarization, speech recognition. Some of these things you're familiar with in practice. Speech recognition is used in systems like Siri or Alexa, for example. Machine translation is using Google Translate, etc. So even if you may not be very you may not realize this, you're dealing with some of these deeper kind of NLP tasks as well. So the simplest of these tasks is basically entity recognition in text. Given a sentence, identifying what are the things that are being discussed in this text, like people or organizations and other things. So this is what's called a named entity recognition. And building upon that, we have relation extraction, where we were trying to identify relationships between entities that are discussed in text. That, for example, in this text, for example, that a person is employed by a corporation, etc. So the representations that I show at the bottom are things that computers can do something with, whereas the text itself can't really do much with. So we're basically helping computer represent the information in the text in a way that it can do something, but it can reason with, it can work with. And for example, one of the applications of this kind of named entity recognition and relation extraction would be to use them for semantic indexing of publications, scientific publications. Doing that automatically. Normally, the librarians spend a lot of time basically manually indexing things, but here it's automated from the words and phrases in the sentences of the article. We can create a sort of indexing terms from a controlled vocabulary like match medical subject headings in this case. So, which is telling us at the bottom here that this article is mostly about artificial intelligence, etc. And this is done through named entity recognition, other things that are related. So, and this can be used also for creating knowledge bases of information. In my field, we create, for example, genetic databases from the text that we're processing and interpreting. But there are other things similar that we can do as well. On creating the countries, creating a list of countries with the largest population based on their Wikipedia pages could be something like that, for example. And in the last several years, a huge emphasis on conversational agents or chatbots, and this is also based on, this requires a deeper understanding of text than you get with text analytics. And here it involves not only natural language understanding, but also speech recognition. So turning the signals into words, understanding the intent of the question, looking it up in a database of some sort, and generating a natural language response as well. So this basically involves all kinds of things that we discussed under natural language processing. And as you know, they're becoming very good at what they do these days. So now I will say a few words about what I do personally in text analytics and NLP. I'll talk about a few projects that I'm pursuing right now. So this is more research. So first thing that I've been working on for a long time is biomedical relation extraction. So specifically from scientific publications. So I'm trying to basically extract the core claims and ideas from individual papers and representing them in a format that computers can understand. And I'm doing this using a tool called SEMRAP. This is a tool that I developed, and it extracts subject, predicate, object triples from scientific literature. An example is shown here. From the sentence, chloroquine and hydroxychloroquine have been used for the treatment and prevention of malaria. We create a triple like chloroquine treats malaria, and we map basically the entities here, chloroquine and malaria, to medical databases. UMLS is one such database. So this is pretty basic research in biomedical NLP, and we use this to process the entire biomedical literature, and we create a database from this that we call SEMMADB, which currently contains over 110 million relationships from all the abstracts of in PubMed database. So there's about, I think, 30 million articles in that data set. So and we're generating over 100 million relationships from that. So we provide that to the community as a service, basically. And it's been used for a lot of text mining, data mining, artificial intelligence kind of studies, and biomedical discovery as well. And we actually used it to basically identify drugs that can be repurposed for COVID-19. Last year, we drew from the SEMMADB database, and we did some processing. We created this whole, basically a graph, a knowledge graph of all the knowledge in the biomedical domain as extracted by SEMRAP. And then we use what's called link prediction or knowledge graph completion methods. These are machine learning methods to basically identify drugs that exist that have not been used for COVID-19, but could be useful for COVID-19 based on the patterns that we observe in this graph. And we wrote a paper about it. So that's another kind of research that we've done recently. Totally somewhat orthogonal to that line of research. I'm also very interested in quality of scientific publications, how strong they are methodologically. And one thing that we've done recently is looking at the reporting quality or transparency of clinical trials. Clinical trial publications. Clinical trials are considered the best kind of evidence for drugs. If you show the efficiency or efficacy of a drug in a clinical trial, that generally goes to market. So it's a very important kind of study, but generally there are a lot of problems in their transparency and their quality. And I'm developing methods, text classification methods, basically, to find out how well they're reported. And we've also applied kind of similar ideas in a recent study on screening COVID-19 preprints. Much of the literature on COVID-19 appeared as preprints, which are not peer-reviewed. So the quality of these articles are sort of questionable. So we developed, or I used some of my tools and other researchers all over the world, in Europe, Australia. We kind of combined our resources to basically develop rigor and transparency metrics for these articles. And they're becoming part of an automated kind of screening of these articles, which, as I said, do not go basically through a peer review in the early stages, at least. So that's kind of some of the things that I do in NLP and text analytics. I do basic research, but I also apply NLP methods to basically answer practical questions as well. So now let's move on to kind of text analytics, how we can get into text analytics, and what are the career paths that are available in text analytics. So first of all, I like to say that with some basic programming skills and some statistics knowledge, it's very easy to get started with text analytics. At least the first part that I talked about, where we're talking about sentiment analysis, opinion analysis, etc. And many online courses are available on these topics on Coursera, Udacity, etc. And many tutorials on various websites like medium.com and other places that you can easily find. And there are a lot of annotated, labeled data sets that you can also just practice with on Kaggle and other competition websites like that. There are many data sets, and this is really what pushed NLP and text analytics to be so successful in the last 10 years or so, the amount of data that's available. So a lot of things are publicly available and you can just work with them. Python is currently the most popular language, and it comes with a lot of libraries that are actually developed for text analytics. So it's very easy to get started with Python when you're interested in text analytics. And in a kind of a more formal way, many information science programs offer courses on text analytics and related topics. At the University of Illinois, we offer courses on text mining, which I sometimes teach, information retrieval, data mining, machine learning, introduction to data science or methods of data science, data visualization, data cleaning, digital humanities, which does some text mining as well. So there are many courses that are relevant that would be useful when you want to do text analytics. And we have a master's program in information management, and they have a data science and analytics pathway. And a lot of the students in that pathway take most of these classes. So that would be a good way of kind of getting into text analytics as well if you're interested in a more formal education or training there. And as I said, NLP can go deeper than that, just the text analytics. And sometimes you want to learn more about the math and theory behind NLP or machine learning, in which case computer science programs generally offer more theoretical or more math-oriented versions of NLP, and also other kind of topics that are related, but kind of more on the tech side or more on the basic math side, such as artificial intelligence, deep learning, or optimization. And these are the courses that my PhD students take generally. But if you're only interested in kind of a more practical kind of career path, then these are not really necessary, I would say. And if you're also interested more in kind of learning how, how language works in general in a kind of computational way, what are the computational theories of language learning, for example, then computational linguistics courses in linguistics program might be also kind of relevant, but this is kind of more on the linguistic side of things. As I said, there are many libraries for text analytics and NLP available. Most of them available in Python. We have Stanza, for example, for various kinds of linguistic pre-processing. And LTK has been very popular. It's been around for a long time. These days, Spacey is quite popular for text processing as well. Then they have a lot of things like sentiment analysis and things like that you can just use off the shelf. They may not work very well for your data, but it's a good starting point generally. And Elasticsearch has a lot of information retrieval kind of capabilities. And I think they're all available in Python, basically. In addition to text analytics and NLP-focused libraries, you probably also will be dealing with machine learning libraries. And again, Python provides scikit-learn library, which is great. It has everything that you really need. And in my text mining course, for example, we use that in projects, etc. But if you're interested in just kind of taking small steps in this direction, there are also GUI-based tools like RapidMiner or Orange that actually does a lot of things in the background you don't really need to know. You really kind of just put things together in like a Lego blocks, and does a lot of things behind the scenes. They could be also appropriate places to start, as well as Weka. MATLAB and R have been around for a long time, and they also have some of these capabilities. On the right-hand side, TensorFlow, PyTorch, Keras, these are deep learning libraries implemented in Python that if you're interested in neural networks, AI kind of cutting edge technologies. These are really where it's at. So you need to probably learn more about that. So what are the career, in closing, what are the career opportunities that you might have in text analytics and NLP? It's a hugely growing market. Currently, it's valued, NLP market is valued at $10 billion and is expected to reach 48 billion in 5 years. So it's growing immensely, and this is driven by basically deep learning AI algorithms that have shown great promise, and it's being used in a lot of things that you actually deal with, like Siri or Alexa. And increasing use of smart devices and systems like the ones that I just mentioned are driving some of these growth. Automated chats and customer service chatbots, etc. I mean, these are all behind the growth in this area. In healthcare, we need to do a lot. We need to understand what's in. We need to understand better what's in electronic health records or the patients, and basically find ways, for example, to alert them about the adverse effects of drugs that they might have, etc. I mean, and there's a lot of NLP going on in that area as well. And recently, of course, with all the disinformation, misinformation going on about COVID on Twitter or other social media, these companies are putting a lot of effort in also monitoring and tracking social media activities using text analytics and NLP as well. So what are some of the positions that are advertised on text analytics and NLP? Generally, you will find these under data scientist advertisements. You can see, you will see sometimes text analytics as well, but data scientist is expected to generally be able to be comfortable with a lot of the text analytics tools. You need data science and machine learning skills to get these jobs. And a lot of it kind of depends on using existing NLP libraries and tools. And some big tech companies also have their suites of tools, NLP tools, that they have things that include sentiment analysis and whatnot, like Amazon Comprehend, IBM Watson, etc. And some of the positions basically advertise knowledge of these, look for these skills as well. So a lot of it is basically using existing tools and fine-tuning them or basically tweaking them in ways to answer the questions that you're asking. But as a data scientist, you're expected to be able to adapt to recent developments, be up to date on what's being developed, and generally an MS degree would be needed, although a BS, a student with a BS degree with some background or some experience could get some of these jobs as well. And then we have NLP engineers who are basically putting together systems that are based on NLP, and these generally have more software engineering skills in addition to data science skills. And most of the development here is in Python, Java, etc. And most of the jobs that I saw when I looked it up were basically chatbots and recommendation system kind of things here. And you're expected to identify, implement new technologies, and again, being up to date on what's happening currently as the field is growing or evolving so fast is important here. And generally, as a software engineer, you're expected to know about cloud infrastructure and big data frameworks like Apache Spark, because you want systems that can scale and to many users. And basically, so that requires a lot more in the engineering aspect of NLP as well. And generally, a MS or sometimes even PhD can get these jobs. And then we have NLP researchers, people like me, or people in academia or in big tech companies. Big tech companies have a lot of NLP researchers. There's a movement from academia to these companies. because most of their tools and most of their basically devices and etc. that they're building are based on NLP. So Google, Facebook, Twitter, Amazon have a lot of NLP researchers. These people not only use existing tools and methods, but they develop them, or they basically create new ways of doing some of these tasks. So it's more research oriented, and typically a PhD would be needed for these jobs. So to summarize, I hope I gave a good overview of text analytics and NLP and careers in them. Text analytics is about understanding patterns and trends and gaining insights from text data in order to be able to make informed decisions. Text analytics is applied, and at the foundation we have NLP and machine learning and information retrieval. Language is hard, and so there's a lot of pre-processing that needs to be done to be able to deal with text using computers. But still, most of the things that we're doing right now in text analytics and NLP do not really understand text in the way that a human understands it. So it's based on sort of statistical correlations that we observe in the text, but we can't really call it understanding in the same way that we understand text. So there's still a lot of research potential there, basically, and things will probably get better in that respect in the next decade or so. So with the information science education, you can get some of the basics in these areas, and get a practical introduction to text analytics. And this is a hugely growing market, so there are a lot of job opportunities, career opportunities here in industry, in academia, as well as government, where in my previous job, I was a government scientist who worked on NLP, and there are many people like me there as well. So that concludes my talk. I know that I'm a little bit over time, but if there are questions, I'll be very happy to answer those. And yeah, thanks for listening. All right, so I'll go.
Presentation, thank you.
Thanks. So I'll go over the questions. Wow, there are a lot of them.
I've been monitoring the chat. I can read them off to you if it would make it a little easier.
Yeah, thank you.
Okay.
Yeah.
You're welcome. So the first one is sentimental analysis part of text analytics? And how can we analyze sentiments from the social networks that can help in measuring customer perception towards a particular brand?
Yes, sentiment analysis is perhaps the most common use of text analytics. So the idea here is basically, collect some data, and sentiment analysis is a text classification task where you're basically saying it's positive, this tweet is positive, this tweet is negative, and this tweet is neutral. So it's a text classification task. And there are several algorithms that I mentioned, like logistic regression, neural networks that you can use for this. The first step would be to have some labels for these tweets, for example, and then you can use standard basically algorithms to do this. What they're going to be doing is basically learn how words are correlated with these labels. So a word like happy would be potentially correlated with positive sentiment. A word like terrible, could be correlated with the negative label, etc. So it's basically going to be learning these patterns. This is automatic. You don't really do anything there. You're just applying by selecting an algorithm to do this. You're basically baking in some of the assumptions that those methods are making into your sentiment classifier, essentially. Does that answer the question?
They said that it did, yes. So thank you, Sparsh. Okay, so the next question is there a difference in the difficulty or success of text analytics depending on the type or topic of text? So for an example, natural science papers versus social science papers.
Oh yeah, it's certainly there's a difference, I mean, I've been working in scientific publications for a long time because it's difficult, whereas news articles generally are easier to understand, both for humans, but also for computers. They're well-formed texts. They're well structured texts, and the things that are discussed in the news article are generally, you could say, a little easier for a computer or for machine learning algorithms to figure out. Social science versus natural sciences. I haven't really looked at social science texts, and there's less work on that compared to natural sciences, I have to say, or medicine, for example. I expect it is equally hard, if not harder, but I haven't personally done any work in that to substantiate that. So I'll just leave it at that.
Great,
but certainly there are differences in the types of text, in the difficulty of the types of text that we deal with. And tweets is another kind of extreme. So on one hand, you have really well written, but really complex texts like scientific publications. And on the other hand, you have tweets. These are super short, not well formed, a lot of irregularities. So these are kind of the two ends of the spectrum, and there's a lot in between, I would say.
Great, thank you. The next question is being framed from a nonprofit or human rights background. So can the stock market prediction analysis of what people are saying about a company be used to predict if a society is becoming unstable, or if there is conflict growing, or if a certain group is being targeted?
Oh yeah, and there's research in this area for sure, looking at tweets and sort of making predictions about I guess the health of a society in a way. This is not. I mean, if you can pose this as a text analytics or NLP question, you might be able to. The problem here would be, I think, gathering enough data. How would you label this exactly? And those are some of the questions. I think there's more work on sort of targeted tasks here, such as hate speech, for example, identifying hate speech from tweets or other social media texts, disinformation, whether some text is condescending towards some minorities or some groups. There's a lot of research going on in this, and I will also I will speculate that some of this is probably making it into the workflows of some of the social media companies at this point, I think. So there's a lot of research on that, but whether whether we can ask larger questions, whether we can answer larger questions about the society using the methods, I think that's less well developed, I would say.
Okay, thank you. The next question is referring to the COVID-19 study that you worked on. So for the clinical trials, would the studies be meta-analyses of many different trials or analyzing one particular trial?
The work that I talked about was analyzing individual trials, individual trial papers. But we are also thinking about, expanding that to extracting information from meta-analyses and systematic reviews as well. And one of the reasons we're doing what we're doing is to help with that process. So people who are doing meta-analyses and systematic reviews spend a lot of time doing those, spend years, because the information from individual trials are not easy to extract or understand. So we're also sort of trying to help them by extracting information about individual trials and organizing them in a way that's more accessible to the systematic reviewers and meta-analysts. So we're working on that kind of tasks as well.
Okay. So the last question that we have here is, do you think text analytics is becoming less linguistic and more statistical? And then it's a two-part question. So how may the questions that computational linguistics ponder change in the future, specifically in regard to text analytics?
That's a very good question. I mean, text analytics has been statistical since it started. I mean, I would say it has a history of about 20 some years. It kind of took off in the mid-90s, really. Before that, there was a lot of research in computational linguistics and natural language processing, because that field goes back to, I would say, to 1950s, and it started with machine translation, basically Russian versus English in the context of Cold War. So text analytics as a sort of a more practical discipline application really has started with the 90s, and from the start it has really relied on simple textual clues. It has never been very deep in that regard. Some parts of natural language processing have done some more kind of linguistic-y things, essentially. But just to say, I think the second part of the question was about how to do questions in computational linguistics affect how we think about text analytics. Was that the question?
Yes, so it's how may the questions that computational linguistics ponder change in the future, specifically in text analytics?
So text analytics is, in a way, perhaps moving from, sentiment analysis and opinion analysis. These were kind of the driving forces for a while. But now we're talking more about conversational agents and chatbots, etc. So this kind of thing requires a deeper understanding of text, and that's where kind of the more linguistic aspects of natural language processing, natural language understanding or natural language generation sort of play a role. And therefore, I expect those things become more and more relevant, even for a text analytics career, for example. You would not be simply, I think, do just text classification, which is the sort of simplest kind of thing you can do, but more about, also developing or tweaking natural language understanding systems. Some models that exist, for example, we have very large models these days that can create really coherent text from a prompt, what we call transformer models. So those kind of learning more about those would become probably more relevant for even a sort of a text analytics versus NLP position. I hope that answered the question.
I think so. They said thank you. So you answered it for me, at least. So I do want to mention that we are a little bit over time. It is 11:03, and I don't want to take away from any other INFOcon participants' presentations. So thank you to everyone who joined us today. If you have questions for Professor, I'm not going to say your name properly. Can you say it one more time for me, Professor?
You can just use my first name, Halil. It's good. Halil,
are you sure?
Is my full name. Yeah.
All right. All right. Well.
Yes, I just want to say that you can find my information on Google, certainly. So you can send me an email if you're interested in sort of OVR more questions, all of you, and I would be happy to answer those. So thanks for coming, and yeah, I think this was hopefully useful.
Yes, I put your email in the chat box. Also, if you have questions about the iSchool or the programs that we offer for graduate students, this is an email that you can reach out to as well for more information. But thank you so much for joining us today. I am going to stop the recording, and this will be made available to participants later, either today or maybe tomorrow. But thank you so much. We hope that you have a wonderful day and enjoy the rest of INFOcon. Make sure that you check out the presentations that are going on today, tomorrow, and Thursday as well. We've got a lot of really great faculty members from all over the United States and in Canada So make sure that you check out our schedule to visit another professor and learn more about the myriad of professions and expertise that we have in information sciences. So, thank you.
Thanks.